And we were talking about the referred pain. And the rule again, if you are talking about any tract, and understand this, if you're talking about any tract, remember that, see the name. It will start from something and go to something. If you know by location it's going up, you're carrying type of sensation or motor command? Sensation. So like spinothalamic tract. Is it going up or going down? From the spinal cord to the thalamus. So it's going up. So it's carrying what? Sensation or motor? Sensation. What kind of sensation? Tell me what's the function of the thalamus. I will tell you what type of sensation. Function of the thalamus is most important one. Pain. Pain has to go to the thalamus first. And the thalamus will filter it out. Should I send it up more to the cortex or not? If it is something that's sharp pain, something that's very important, the thalamus will send it up to the cortex. If it is something like dull, aching pain, burning pain, something like that, something of that nature that's chronic type of pain, it will not be sent. Maybe the cortex will be kind of aware of it a little bit, but it's not going to be fully sent to the cortex. So remember this rule. See the first part of the name, the second part, know if it's going up or down. If you know it's going up, it's sensory. You know it's going down, it's motor. And then the second part, where are you going to? If you're going up, thalamus, it's for pain. In this case. These are different examples of the referred pain. If you feel pain in the right shoulder like this, and of course I'm talking about, remember this, when I talk about the referred pain, I'm talking about the skin. So don't tell me I have pain in my right shoulder inside, like in the joint. When I move my joint, I feel pain. No, this is not referred pain. Referred pain is skin. So when I say right shoulder, I mean the skin of the right shoulder. If I say the left shoulder, I mean the skin of the left shoulder and arm, in case of the heart, for example, and in case of the gallbladder and the liver and the left side. This will be in the colon, this part. This is periumbilical, this will be for the appendix. This will be for the stomach. And again, the rationale is, the reason is that the sensory neuron that carries sensation from this piece of skin come together very close and share part of the innervation coming from the other organ. So the gallbladder, sensation from the liver and gallbladder, and sensation from the right shoulder, from the skin of the right shoulder, will come very close together as they go up toward the thalamus, and they stimulate each other. So the brain will receive it as coming from the shoulder rather than the gallbladder. This is the spinocerebellar pathway. Can you tell me if it is sensory or motor? Can you tell me first if it's going up or down?
Or no?
Going up? So is it sensory or motor?
Sensory.
Motor.
Okay, remember this. When you go up, you go to the top management. Do you give commands and orders to your manager? Or give information to your manager? Information. And you take orders from your manager, right? So if you're going up, you're going to the top management, you're giving the top management information. So it has to be sensory. The top management, which is the cortex, whether the cortex or anything above, that will be the upper management. So it will give you an order, which is a motor command. So this is going up, carrying sensory or motor? Sensory. And it's going to the cerebellar. What kind of sensation is carried here? Tell me what's the function of the cerebellum. I will tell you what kind of sensation is carried. What's the function of the cerebellum? BPM. BPM. Balance, position, and muscle movement. Don't forget this. What's the function of the cerebellum? BPM. BPM. Balance, position, and muscle movement. So of course now you know that if I ask you what type of sensation is carried on the spinocerebellar pathway, you know it's balance, position, and movement. Not necessarily that I will give you the three of them in a question. If I ask you balance is carried on which tract? Of course you know it's this, right? Muscle movement, this. Position, this, right? Pain, spinothalamic. Did you get the concept? And at any time when the information go to the cerebral cortex, you are aware of it. You are aware of it. So your cerebral cortex is the highest management. Yeah, the brain is high management, but the highest of all is the cerebral cortex. Anything that goes to the cerebral cortex, you will be aware of it. If it is shielded, or if it is obstructed before reaching the cortex, you're not aware of it. The visceral sensory pathways, which is the pathways that carry sensation from the viscera, and the viscera is everything inside your trunk, anything in here, this will be the viscera. This will be picking up the sensation from the interoceptors, which are the receptors inside, receiving signals from inside. And it's not as much as somatic. That's why it's usually L-defined. It's not as much defined. So you can tell exactly if it's something in your skin, you can tell it's exactly in this point. This is usually not the case when you come to the viscera because it's not as much. You don't have that much receptors. And it can be nociceptor, thermoceptor, tactoreceptors, baroreceptors, and chemoreceptors. What carry these types? Cranial nerves. 5, 7, 9, 10. These are the most important ones that carry your visceral sensory pathways, not like the somatic nerves, not the spinal nerves. These nerves, 5, 7, 9, 10, and you need to remember that, these will carry visceral sensation from this part, okay? You name it, starting from here and going all the way down until the esophagus, that will be 5, 7, 9, 10. And it will go up to the solitary nucleus in the medulla or the medulla oblongata. Now the somatic motor pathways, is that going up or going down? The pathway is going down. Okay, when we said when you're going up, how many levels do you go to? 3. The first one is first order, the second is second order, and third order neuron. When you're going down, you go to 2 steps only. You go to upper motor and lower motor, not like the sensory. So when you go up like this. 1, 2, 3. While if you go down, go like 1, 2. Okay? You go up in 3 steps, and you go down in 2 steps only. Upper motor and lower motor only. The upper motor neuron is the upper part, the first part up there, and that will start from the CNS centers, from centers in the CNS that will give the motor command, and of course it will be going down. And it will go to the motor neurons. Lower motor neuron will come from the brainstem or spinal cord and go down all the way to the organ. Okay, so upper motor neuron start from the motor centers in the brain or the cortex and goes down to the brainstem to the nuclei in the brainstem or spinal cord. From the brain and spinal cord, the lower part will take it to the muscles. Okay? So if this is upper motor neuron, starts somewhere like in the cortex maybe, okay, in one of the nuclei in the brain, and it will take it either to the brainstem or to the spinal cord, and that's it. This is the first one. To the nuclei in one of these. This is the upper motor. The lower motor will take it from there and leave, go for the muscles, for example. So we have only two, right? From the nuclei up here, or from the centers, whether we're talking about the cortex or the brain, to one of the three parts of the brainstem, or to the spinal cord, right? From cortex or brain to brainstem or spinal cord. This is the upper. From the upper to the organ, which is usually muscles, that will be the lower motor neuron. So you go in two steps. What are the types that we need to know? There is corticospinal, there is medial and lateral pathways. And of course that will be carrying motor command. These are examples: rubberospinal, corticospinal, vestibulospinal, reticulospinal, tectospinal, other corticospinal. And I know that, like, if you started from this one, corticospinal, where does it start from? Cortex, and go to the spinal cord. Rubberospinal, I know that you're not aware of this one probably, and rubbero means the red nuclei in the brainstem. So you start from the brainstem going to the spinal cord. Okay? Vestibulospinal, it comes from the vestibular nuclei in the brainstem and go to the spinal cord. Reticulospinal, start from the reticular formation in the brain and go to the spinal cord, and so on. Tectospinal, tectum is part of the midbrain, so it goes from the midbrain to the spinal cord. So starting from any part above and go down. Corticospinal, they start from the cortex and go all the way to the spinal cord. There is lateral, and there is anterior, and the important thing here is it looks like a pyramid. It goes like this, coming from the cortex, and it go down like this, 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 this. So if you look at this, kind of looks like a pyramid. So the pyramids are these corticospinal tracts together. Now the motor homunculus. We talked about the sensory homunculus, which is a map of the whole body in our cortex, so that when you stimulate part, touch, paint something, when you stimulate it, it will go to the cerebral cortex and stimulate part, and your cortex know that this is coming from this part. Remember when we talked about, like, you're in a control of different phones, and you know this phone is coming from this area and so on? It's the same thing. And the motor homunculus is the opposite. It's kind of similar. It's a map of the body, but instead of receiving sensation and be aware of it and translate it, it's the opposite. This is where you start the signal from the motor homunculus, and it will go down all the way to the organ itself. And of course, it's the same thing. Obviously, the motor, the movements of your fingers and hands, this is very complicated. So it will be represented as large parts, just like the sensory homunculus. And the other part, something like the trunk, will be represented as small. And here it looks like this. which is kind of similar to the sensory homunculus. So this is the motor homunculus. See how the hand is too big? Because you do a lot of fine movements with your hand and your fingers. So this is the motor homunculus right there. And this is coming from the cortex and descending down. And it will go all the way until it go to the skeletal muscle. But you notice here, a good part of it will be crossing to the other side. Do you notice this? Look at this. If you go, what is this part first? What is this? Pyramid. Are we following? Look at this part coming from the cortex, the red, and this. Does it look kind of like a pyramid? Yes? So this is the pyramid, which is the part of the corticospinal tract, the upper part, and then it will go down, follow, going down, and then it's crossing, right? A good part of it will be crossing. And how did they realize that? This is just for your information. They got something like a frog or something, and they took the brain, they opened the head, and they start to touch different parts. Let's touch this part. You see, they see the fingers of the frog moving. Oh, so this part of the finger, for the fingers. Let us touch this part and see which is moving. The hand is moving. Let's touch this part. The lower limb is moving. Oh, so this is for the hand, this is for the face, and so on. And they noticed that when they touch the right side, that's expected for the hand, the left hand is moving. And this is how they know. Of course, later on, they did the dissection. They got some more advanced techniques. But at the beginning, this is how they realized the crossing. You stimulate the right part, and the left hand moves. Oh, so it crosses. This is how they found the crossing, which is called the decussation of the pyramids. This part right here. So this is for the cortical spinal tract. Now the medial and lateral pathways. They start from the cerebrum, diencephalon, and brainstem, one of these, which is the start. The start of the corticospinal was from cortex. The start from the medial and lateral pathways from any one of those. Cerebrum, diencephalon, or brainstem, which is basically everything above the spinal cord. The medial pathway, the medial motor tract, is going to control the movement of the trunk and proximal limb. The lateral will control the distal limb. Okay? Are we following so far? The medial pathway, this is what you have to know. The medial pathway will control trunk and proximal limbs. The lateral pathway will control the distal part. So if you compare the three descending tracts, the three cortical spinal tracts, it will be, all of them will be starting from the primary motor cortex. And the primary motor cortex is the cortex, or the part of the cerebral cortex that starts all the movements. Movements will start from there. The voluntary movements start from there, and there is a part that they will cross in different parts. Can be cross in the brainstem, pyramids, or spinal cord. Medial pathway and lateral pathway. Medial pathway can be any one of those three. And the most important thing to remember about these pathways is which part. So the medial pathway is the trunk and the proximal. The lateral pathway is the peripheral part. Basal nuclei. What is the function of the basal nuclei in relation to the cerebellum? We know the cerebellum already, BPM, right? Balance, position, and muscle movements. How about the basal nuclei? The basal nuclei, they control, just to remember it, the basic pattern of the muscle movement. Just to remember it, okay? the basic pattern of muscle contraction. Basal nuclei control the basic pattern of muscle contraction. They coordinate and control the muscle contractions, which is the basal nuclei. What are the basal nuclei? These are nuclei inside the brain. Do you remember when we said like the brain is like a watermelon, the green cover from outside? This is similar to the cortex. The red filling inside, this is the white matter, which is the brain tissue itself. And if this is seeded watermelon, the seeds inside are these nuclei. So we have nuclei that's embedded inside the white matter. It's a group of bodies inside the white matter, and each one of them is doing a function. The most important thing to remember is coordination and pattern of movement or muscle contraction. So they do the basic background movements or skeletal muscle contraction or muscle movement. Okay? I'm not focusing on everything. Whatever I'm focusing on is the core that you have to know. Did you notice that? Okay, so focus on this. You can read the rest, but you cannot forget what I'm focusing on. Okay, so for the basal nuclei, or the basal nuclei, background pattern and coordination of the muscle contraction or muscle movement. This is what you have to remember. Everything else, read it, that's okay, but don't forget this. Cerebellum, BPM, position, balance, position, and movement. BPM, balance, which is coming from the vestibular sensation. Position, which is coming from the proprioceptors. What are the proprioceptors? Receptors responsible for what? Do you guys study as we go? What are the proprioceptors? Receptors responsible for what? Where is it located?
Oh, the position of joints.
Yes. And where is it located? Joints, muscles, and tendons. Don't forget this. It's located in the joints, muscles, and tendons. Why do we have proprioceptors? To give us an idea, to give your brain an idea about the position and movement of your joints. And this is exactly how you tell. If I ask you to close your eyes and start to move your muscles like this. If I'm closing my eyes, it's now like 90. I'm flexing, I'm extending, right? Rotating. How did I know? Proprioceptors inside my joints are telling me exactly about my position. I'm contracting, relaxing, contracting, relaxing. How did I know? Proprioceptors inside my muscles telling my brain if I'm contracting or not. Don't forget this. So BPM, balance from the vestibular, sensation of the inner ear, position, which is from the proprioceptors, and muscular movements that's coming to the cerebellum to have this balance altogether. The visual information coming from the eye. The thing here is, when we say that the cerebellum is the organ that controls our balance, in order to be balanced, do you know that if somebody having an inner ear infection, they lose their balance? Do we know that? If you have infection in your inner ear, you can fall down. You don't have a problem with your muscles. You don't have a problem with your brain. There is nothing wrong. And then you feel like you're not balanced and you cannot walk. You have to sit down. If you started to walk, you'll fall down. Why? Because the cerebellum is controlling the balance. How to control the balance? You have to give the cerebellum enough information to control your balance. Where do you get the information from? From proprioceptors. So you need to know the position of your muscles. So if you are moving like this, right? If I'm flexing the right and extending the left, and then I do this, opposite, right? I'm flexing the left and extending the right. This is how we move. without falling down. We move on two limbs only, right? And we don't fall down. How? Because this movement and the position of the joints go to the cerebellum, and the cerebellum will coordinate. You're flexing this, we have to extend this. I know the position, I can control it. So in order for the cerebellum to control your balance, you have to give the cerebellum the tools to give you the balance, right? So what are the tools? Number one, proprioceptors. Receptors that give the cerebellum information about the position of the joints. That's number one. Also, the condition of the muscle. Are you contracting? Are you relaxing? 2. 3. Inner ear. The inner ear has to send the information to the cerebellum so that if you do like this, if you close your eyes, I'm bending to the right, I'm bending to the left, how did I know? The inner ear, there is a fluid. Did you see how the builders use something that have the water level and they know if it is balanced or is it tilting this way or this way? Did you see this before? Yeah. They have a tool. We have something exactly like this inside our ears. So if the fluid level is like this, means you're balanced. If you do like this, the fluid level will do like this. And it will give information to the cerebellum. You're tilting to the right. You're tilting to the left. Right? So this is another information that your cerebellum needs to know in order to keep your balance. Also the visual, the vision. Doesn't it make a difference when you're opening your eyes and walking versus if you close your eyes? You can lose your balance and you can fall down if you close your eyes, right? Try it, close your eyes and try to walk. I'm not saying something in the way, even if there is nothing. You might fall and you might have disturbances of your balance because you need an input from your eyes as well. Okay? So what are the tools that the cerebellum needs to give you the balance? Proprioception, vision, and hearing. Okay? Which is vestibular for balance, vestibular from the inner ear, vision from the visual information from the eye, proprioception, which is the position coming from the proprioceptors that are located in the joints, muscles, and tendons. Okay? So that's it for this part.